Morning to everyone. This is Rich Uganian. I'm Vice President of Investor Relations for Cerence. Welcome to our first technology showcase. This event will be very different in several ways from past events. First of all, the event will be hosted by Prateek Kathpal, our Chief Technical Officer. Sanjay Dewan, our CEO, and Mark Gallenberg, our CFO, will be in the audience just like the rest of you for this event. Secondly, this event is solely focused on helping analysts and investors gain a better understanding of Cerence's products and our innovative technology. So financial related topics will not be covered during this call, just so you're aware of that. And finally, because of time constraints, we're not taking any questions during the event. However, if you do have any questions, please feel free to follow up with me afterwards, and we'll make sure to get an answer to whatever question you may have. Before starting, I just want to caution everyone to our safe harbor statement. Please read through this at your leisure, or any of our SEC filings as well. So let's get going. I'd like to hand the call over now to Prateek, our Chief Technology Officer. Prateek.
Thank you, Rich. Well, hello, welcome everyone. I'm Prateek Kathpal, CTO at Cerence. We at Cerence are involved in creating the world's best in-car experience. We're an interactive artificial intelligence company, and we use AI and deep learning to provide the experiences beyond the voice. So if you look at Cerence today, we have about 325 million plus cars on the road, and 1 in every 2 cars shipped globally in 2019 had Cerence technology. Now we have received several requests from you guys over the past few months that you would like to learn more about the technology, understand how it comes up together, and how the solution gets used. So Cerence today, as an organization, we have more than 1,800 developers, and these are speed scientists and experts worldwide. They are involved in various stages of the vehicle development, architecture, and have a wide array of the knowledge and experience in AI, in deep learning, and neural networks. Doing AI itself is not that simple, but creating a delightful, intuitive experience and bringing it together using voice, touch, gestures, emotions, and gaze adds a whole new layer of complexity. Now, when you add on top of that 70 plus languages support with a moving vehicle where the environment is typically not within your control, you can have, let's say, the engine noise, the road noise, or various external elements. You're talking about a very, very complicated system working together to create a human-like experience. So the purpose of today's session is to educate, to showcase some of this technology behind. What you guys see in your daily life in the cars you're driving on the road, we'll talk about how those cars are powered and what's the technology behind from Cerence side in some of those. So with that, we'll talk about what we are going to talk about today. So we have a very full agenda today for the next 90 minutes or so. I'll start by talking about how AI is humanizing your car. Followed by me will be Udo, who will talk about the building blocks of conversational AI. After which, Christoph will talk about multimodality components in interactive AI. George is then going to dive into how these interactive AI blocks of conversational AI and the multimodality components, how all these can be assembled into turnkey solutions. Then Nils is going to talk and discuss about some of the applications that are based on top of this technology. Now, no solution is complete without a great UX. So Adam will talk about how we invest into creating amazing experiences for the users in the vehicles. We'll then have a guest join me for a virtual chat. We'll have Charan Lota, Chief Engineer, Connected Technologies at Toyota North America, join us for a discussion on the role of AI in the future connected vehicles. And finally, in the end, we'll have Rick, the CMO at Cerence. He'll talk about how all this technology and innovation, how it comes up together to deliver a great experience, and he'll cite a real example over there as well. With that, let's get started. Next slide, please. So, next slide, please. Now, when you talk about a complete in-car experience, several different things come into play. Human-machine interface, or HMI, as we call it as well, in its simplest terms, includes any device or software that allows you to interact with a machine. This can be a simple touchscreen display mounted on a machine, or it could be a very technologically advanced, multi-touch, voice-enabled, with biometrics, vision-controlled, and enhanced control panel, which might have even a connection with a mobile technology, such as your smartphones or smartwatches. Now, traditional HMI solutions were standalone, isolated touchscreens. Those that were deployed by the OEMs. But today's new HMI solutions, they require a very integrated approach. They're cloud connected, they're IoT enabled, and they provide a very intuitive and a natural way for people to interact. So when it comes to in-car experience, we at Cerence are redefining this completely. We're using AI integrally in a multimodal form, from voice to biometrics to gaze to gestures. And we're focusing on not only connecting drivers to their cars, but also to their entire digital universe. So we're basically building the heart and soul of the modern car as a part of this. Next slide, please. So a multimodal human-machine interface, or HMI, as I said before, it allows users to control their vehicles using various input modalities. This could be the speech, the touch, the gestures, and the handwriting. Now, it has the potential to minimize the load, the cognitive load on users' brain when performing these complex tasks. And at the same time, makes the driving experience much better and safer. So if you look at a modern car today, we have hundreds of different sensors. They can provide vast amount of real-time information. This could be from vehicle data to road conditions, weather information, and then you have the user data, which is your personal life on the phone, your apps, your preferences, and then finally now the IoT, which is connecting you to your home or let's say some other devices. So this is a very complex ecosystem, right? And it consists of a knowledge graph, your home graph, and even your personal preferences. Since AI and deep learning models use all this data along with neural networks and algorithms to real time, think of it mimics the functions of the human mind and enables you to interact with the system in several different ways. And it also enables the vehicle to respond and take actions without that human intervention needed. So as an example, it enables you not only to adjust, let's say, the temperature, or respond to how much is the gas left in a tank, but it also learns from individual drivers' speech patterns and behaviors over time, and enables you to safely and very intuitively interact with the car through various multimodality components like gestures and gaze and emotions. Next slide, please. So if you look at the profile on your phone, it is very different today than the profile on your car. You might be using, let's say, a phone to dial into your Zoom or your Teams meeting. You might be checking your WhatsApp messages or listening to your music on your phone. But when you sit in your car, you do want to keep your phone in the pocket. But because of the disconnect between a car profile and your phone profile, you're forced to pick up your phone while driving to maybe, let's say, reply to that phone call or reply to that message or maybe even an email. So we at Cerence, as we started defining the car of the future, we did not just start with only how to improve the experience, but we also took over the goal and the objective on how to bring in your personal life seamlessly into the car. So the improvements that we are making are more towards how we can connect these two, your personal life and your time in the car, and not how we can create a new profile of yours in the car. And it's actually very different, right? So you're connecting these two things as opposed to recreating them. Now, let's say the songs that you're listening on your phone, or the music library that you might have on your phone, that becomes very easily then accessible in the car. And then if you, let's say, share your car with your spouse or another user, their personal life, their preferences becomes primary and not yours. Now, with these innovations that we'll be bringing in the future, we're creating a single digital identity inside and outside the car. So we're focusing on creating a digital twin of the car in the cloud. Think of it as a virtual model of the connected vehicle. The digital twins, they allow you to capture the behavioral and also the operational data of the vehicle and result in a very personalized experience for the users. So next slide, please. Now, if you look at the core foundation of Cerence, it is this hybrid edge and cloud-connected AI platform. This is what enables to create a simplified human experience for drivers. But in the back of it is an extremely complicated stack and defensible set of technologies all working together. So it starts with several, I would say, input and AI technologies, including automatic speech recognition, natural language understanding, text-to-speech, and beyond voice, multimodal interactions as well. You'll hear some of the presenters today who go deeper into these blocks as I walk you guys through the agenda as well, and how they're all packaged together to bring an overall solution to the market. And how the Cerence Cloud, which is a key element over here, is scalable and handles 1 billion plus connected transactions in a year. Now, the Cerence Cloud, it acts as a data brokerage, right? So between the third-party ecosystems, between your data, the user data, the vehicle data, and also the environmental information. So it uses this data to real-time enable deep learning, which we can then also use to further train our AI models. But then at the same time, the OEMs can use this data to improve the experience for their users. Next slide, please. Now, when we talk about the Cerence roadmap for immediate future, it's very clearly focused on two things. Enhancing the in-car experience is obviously the first part of it, and we enable the OEMs as a part of this to create a great brandable experience, and at the same time create a great end user experience as well. And the second over here is to innovate with the cloud. So as more and more cars become cloud connected, it's possible now to offload some of the in-car edge computation to the cloud. And it just opens up and enables quite a lot of new use cases that were never possible before. So I'll give you an example. An AI-powered infotainment system will know exactly what movie to play for your kids in the backseat. Or let's say play the song that you like after you had a long day based on your calendar or wake up time. And it enables you to have a much safer journey, and at the same time reduces, as I said before, the cognitive load on your brain while driving. Next slide, please. So the next generation interactive AI is not just a simplified user experience. It also requires the intelligent data to support it, and it needs to be environment aware, it needs to be ecosystem aware, and it also knows about your preferences and connects to your profile seamlessly and enables multimodal decisions and interactions all at the same time. So with this, I'll pass on to Udo to talk about the building blocks of conversational AI, which is a key element over here in the interactive artificial intelligence stack.
Thank you, Prateek. So I'm Udo Heiber, and nice to talk to you all. I'm heading R&D within Cerence, and I'm in the auto and speech industry now since more than 20 years. So I'm excited to have the opportunity during the next 10 minutes to build a bridge that allows you to get some insights and previews on what is cooking in our technology labs. Next slide, please. So I'm going to start off with a high-level diagram on what are the core building blocks and how to use the blocks and how they are being connected to each other. So, but before I talk to the diagram, I wanted to mention that all the technologies in those blocks are used on both ends, the edge and the cloud. That is also why we call it hybrid technologies. So using the same engine in both places is a big advantage, as we are now able to run large deep learning networks also on the edge in real time with state-of-the-art processors. First cars with this new technology will hit the road already next year. So by the way, even though we talk about engines and hybrid in automotive, it has nothing to do with powertrains, and our engines also do not consume fuel as they run purely electric. So now let's move back to the diagram. On the left side, you'll find a user input. In this case, a driver may have said, find a charging station on my way. First thing we do is to clean the speech signal in the so-called Speech Signal Enhancement Engine, SSE. We remove noise and echoes or deal with multiple microphones, for example, to find out from which place in the car an utterance was spoken. So after that, the signal splits and goes into two automatic speech recognizers, one in the cloud and one in the car. And ASR does convert speech into text. This text is then processed by the natural language understanding step, the NLU step, and delivers a language-independent semantic representation of what the user said. This can then be followed by content retrieval on the cloud and is then sent back to the car, where we decide which of the results to use in our hybrid arbitration module. The dialogue engine then finally decides on what feedback to give to the user. And in this case, we'll play a prompt using our text-to-speech engine, TTS, and may also display a map on the screen with the charging stations here. So with that, I move on to the next slide. Now that you have seen how the building blocks work together, I want to dig a little deeper to understand what is inside each block. As you can see, maybe also on the many more acronyms on this slide, all our engines are powered by deep learning models. And the respective models are built on a computer using our own deep learning training toolkit, which is based on TensorFlow and others. So each technology has a set of specific networks to solve specific problems of spoken language. Starting again with our signal enhancement program, the list where you find deep neural net for noise reduction, also for section and for and I will talk more about this technology in the next slide. But the next in the list is speech recognition, which was the first tech in-house to adopt deep learning. We apply modules like detection for acoustic modeling and language modeling. On the NLU, or natural language understanding, we use our the new MPX system of this. And last but not least in the list, there is TTS.
Excuse me, Udo. We're having a hard time hearing you. I think there's some connection bandwidth issue. So maybe what we could do is we'll move on to the next section of Christoph, and if you could dial back in, and we'll come back to yours in a minute. Okay. So can we get to Christoph's section, please? Thank you.
Okay. Thank you, Prateek. My name is, good morning. My name is Christophe Couvreur. I'm head of product at Cerence, and I work closely with Udo on our AI building blocks. And Udo is going to was covering the main traditional building blocks of a speech recognition system and conversational AI system. However, as those systems evolve towards even more humanized interaction, there are more building blocks that come into play, more multimodal, things that go beyond speech. Because we're humans. We have been wired for face-to-face communication over millennia of evolution, and we pay attention, consciously or not, to more than just the words spoken. We notice how people speak, their body language, the context of the interaction, what's happening around us, etc. So a really natural interactive AI should take those other things into account too. Next slide. And starting with the speech output as an example. As you're going to see when listening to a voice, there is more than the words, the tone of the voice, the accent of the speaker, like mine, French, the style of speaking matters to the listener. We notice them, and this impacts how we perceive what is spoken. And for a long time, computers have used the very flat, neutral voices that were technically easy to build. Think of HAL in 2001 Space Odyssey. But now that deep learning arsenal that Udo started to cover is at our disposal, we can create voices that are much more expressive and can achieve near human quality in all aspects, including things that are more subtle, like the emotion they convey, the style they use. An example of that is our latest Cerence Reader product. It's a virtual newscaster that can read news the way a human would read news, including deciding on how to read them, because you're not going to read, say, the sports results the way you would read an obituary. Well, probably depends. If your favorite sports team lost, maybe you would. But normally, you would adopt different way of reading depending on the content. And that's an example that you're going to see here of what the system can do. You can play the example.
Johnson & Johnson begins late-stage trials on a single-shot coronavirus vaccine. The experimental vaccine being developed by pharmaceutical giant Johnson & Johnson is the fourth vaccine to enter the large phase 3 trials that will determine whether they are effective and safe. 3 other vaccine candidates have a head start, with U.S. trials that began earlier in the summer, but the vaccine being developed by Janssen Pharmaceutical Companies, a division of J&J, has several advantages that could make it logistically easier to administer and distribute if it is proved safe and effective.
So, as you could hear, the virtual newscaster picked a style, slightly upbeat. It posed in the right place. You could even hear some breathing sounds. And this makes the voice a lot more natural than traditional TTS voices, which in turn make them a lot easier to listen to for a longer period of time, like on a news text. Next slide.
Johnson & Johnson begins.
Next slide. Thank you. So, as I just said, speech is more than just the words spoken. The tone of the voice matters. But beyond that, what also matters is what it conveys towards the system. So Udo was explaining that speech is converted to text and then processed, which means that any extra information like the emotions, the stress that may be present in the voice has been removed by that stage. But this is also important information. So what we are doing now is we are building new components that can extract that from the speech and other modalities and add them as additional information provided to the system. So we have built an emotion classifier that operates next to the speech recognition system, the ASR system, and classifies the emotional traits present in the voice of the speaker. And with that, the dialogue component can decide how to react and maybe adopt an upbeat tone if the speaker is down, or maybe a more soothing tone if the speaker is stressed. If there are cameras in the car, by the way, monitoring the occupants, this is possible to combine the video signal to do a video-based emotion detection and merge that with the audio information to come to an even better decision. Next slide. So the emotion is one extra information that your voice may carry, but beyond the words and the emotions, your voice also carries a lot of additional information about who you are. And using voice biometry, which is again a technology component powered by deep learning, you can identify the characteristics of the person speaking. Are they male or female? Are they old or young? Are they who they pretend to be? And based on that info, you can adjust the reactions of the system. For example, if the system identifies who the speaker is, it can respond to a command like load my profile by loading your profile and not that of your child or that of your wife. It can also be useful to authenticate the identity of the person speaking. Are they who they pretend to be? And that's important if you want to validate a monetary transaction by voice. And Niels will tell you a bit more about that later. Once again, if there's a camera in the car, what we can do with the voice, we can also do with the video signal. So we can do face biometric next to voice biometric. And combining that with additional information about the car and the car data in the biometric suite, we can do a fusion of those information sources to come to a more reliable and less intrusive experience for the drivers. For an example of that would be if the car is speeding on the freeway and the doors are locked, you know that the driver is not changing, but it shouldn't be. So you can make a decision about the driver, about who's present in the car that is much more reliable because you know it's not going to be somebody from the outside that you have to reject. Next slide. Now, I've mentioned a few times that we have cameras in the car, and those cameras are put in usually for a good reason. You may have been wondering, where does that little pop-up icon on your dashboard, or if maybe your Mercedes, come from? You have that little coffee icon sometimes that advises you to take a rest or to go grab a coffee. Well, it's using an inside mounted camera to monitor the driver for signs of drowsiness. Those cameras are put in the car today, mainly for safety reasons. But once they are in the car, with the AI software, we can enable more advanced multimodal features because we can use those cameras to detect elements of human interactions like gaze, body language, gestures. And when we look at something as we speak, we provide information. We may say, what's this? By looking at someone. We may be pointing at things, we may be doing a gesture. And a real humanized virtual assistant that would act like a human should be able to understand that body language, take it into account in the way it's interacting with the users. So those cameras that are put in for driver monitoring can also be tracking the gaze of the driver. That gaze alone is not sufficient. You need to combine that with additional information. And that's exactly what our Cerence Look product does. So it's taking the gaze information, it's combining that with information about the surroundings of the car, the map data, what is around it, what is visible from the car, which it calculates using a visibility model of the surroundings of the car, the speed at which the car is moving, the location of the car, the timing of the query. And taking all of that into account, it can resolve a request, what is this restaurant, into, okay, the person was looking at this restaurant at that point in time, that side of the road, and fetch from a point of interest database the information about the restaurant and provide that back to the user. So this will give you a very precise answer without having to fetch your phone, without having to look up anything, just by using that information from the car combined with the queries you make to the virtual assistant. Next slide. So far we have been talking about human interaction, But in fact, the same family of building blocks can bring capabilities to the system that are human capabilities and sometimes superhuman capabilities that go beyond what we humans do. So an example of that is emergency vehicle detection. We humans can detect things like noises, other sounds, beyond just the speech. And we can tell which direction the sound is coming from. This is a very useful capability that virtual assistant and cars could benefit from. So the way we have enabled that in the car is having a module that uses the signal of the microphones inside the car or outside of the car to detect sirens, police cars, fire trucks, ambulances. It's deeply integrated with the audio system, which allows it to use the speech signal enhancement techniques that Udo mentioned to remove the echoes from the loudspeakers, from the microphone signal, the background noise, and then detect the siren sounds even when the radio is playing at full blast or the road conditions are very noisy. Once it has detected the siren, it can warn the driver, it can lower the music volume to make you hear the sound of the siren appropriately, or if your car is in autonomous driving mode, it can tell the autopilot that there's an emergency vehicle approaching from the back, and it's time to request the driver to take control, for instance. And those are very useful capabilities to add to the AI in the car. I have a short video illustrating that we can play now. And those are two cars, one equipped with a siren that you see on the side and the black one. We're inside the black car. And the car with siren is in front at this time. And you can see at the bottom, as the car passes by, how it's tracking the direction of the siren, of the car bearing the siren, and it keeps detecting it even as we move further away. And we stop hearing the siren, yet the system is still able to detect it and hear it. What you were hearing here, by the way, was the German police siren. It's one of the things we have learned working in this field. There's a lot of different types of sirens. And if you want to quiz us on what does a fire truck sound in Taiwan, we can answer the question. So beyond the sirens, there are a lot of other warning sounds that are important for the driver or for the car to know about. Things like beeps of backing up trucks, the alarm bells of railroad crossings, which we're adding to the system. So that's it for me. I mean, I've covered some of the additional AI building blocks we have been adding to the system. Those combined with those of Udo, give a broad range of capabilities to the system. But they have to be assembled into a single experience. And that's what my colleague will be talking about. George will tell you about packaging now, how those can be quickly and rapidly packaged to deliver a full solution. Thank you.
Some mobility solutions, IoT technology BU, and Great China. So I spent more than 70 years in Cycmodo, which is the biggest car OEM in China, has a joint venture with General Motors and Volkswagen. So I was the chief architect of the digital technology strategy in Cycmodo headquarters before I joined Cerence last year. So I will talk about how to use the blocks to building the solutions. Next slide, please. So we call the solutions is modularized turnkey solutions because we need to address the problem or pain point of our customers. So today, the feedback from our customers are always talking about a time to market matter. And the car companies realize they need AI digital solutions it's very quickly and sell them because of the digital transformation. So however, to order a seamless solutions in the market is very, very difficult. So sometimes they need a partner, a one-stop shopping partner to help them integrating and building the solutions. In the market of China, especially the low end of car, they need out-of-box solutions, and while customization for the brand and the model. So our customer wants accelerate the penetration and have this penetration base to allow future data modernization and also some real digital business. Next slide, please. Next slide, please. So as my colleague explained the technology before and also the product before, it's very mature and high penetrated across the world. Every 2 cars have 1 car is using the Cerence technology. In fact, we did the experience for 20 years, building very complicated AI solution in the car. What I believe this is the most complicated IoT consumer product. So we invited to build ARC, which is AI reference kit. This platform is not the software only. So you can see it has 4 components: software, best practice, data, and operation. So I will describe it later. So our mission is to accelerate out-of-box solutions to mobility solutions that may be beyond the car. So can move any kind of assets like people or not people. So we're looking at elevators, trains, 2-wheelers, buses, and trucks, and many other industries. In most recently, we have taken the ARC into the 2-wheeler very successfully, the 70-mile e-scooter, and it got a great feedback from the market. I will show the video later. So next slide, please. Okay, let's zoom in. The ARC platform leverage our core conversational AI stack, and it completed setting into the 3 module blocks: cloud, client, and edge. The cloud allows us to deploy the new features in minutes without downloading the software, without downloading the app from the app mark or OTA's head unit. The client allows us to take the traditional head unit from consumption to SOP in weeks instead of the months. And also the edge, it allows us to penetrate deeper into industry IoT, where it's a low or limited computing power, like the TCU, telematics communication unit. In order for us to achieve a very rapid time to market, we have put together and pre-packaged the user interface, including dialogues that allow us to quickly customize the feature sets and the solutions. While leveraging our automated quality assurance, it will ensure a very high quality end-to-end user experience. So this rapid penetration into the IoT devices will generate a large amount of data, which our ARC platform can capture, fuse, learn, and provide the necessary insights. Then connected to our customers' operation backends, they can easily to find the new plan to monetize the data in their digital business. So next slide, please. Okay, here is the slides for engineer. So it's a technology for those who are the engineer on this call. I want to explain the architecture. As you can see, ARC is a multiple operating system across multiple devices. It leverages the advanced conversational AI stack that Christophe and Udo is discussed. But a couple of things I want to highlight here. I think it's very important. So Cerence is known for the great conversational AI technology for the entertainment, the infotainment in the car. But the car's future is not just entertainment, but also control and drive. So we have automated control mechanism across conversational AI and list 200 control features in the car. So you can control the car just by voice without any buttons. So our cars powered by ARC that you can control your sunroof just using, I need some fresh air. I'd like to see the star, not just command like open the sunroof. So as you're driving the highway with the sensor fusion of the car, you can easily say 50 miles per hour, increase to 65, and etc. to start and set the cruise control without worry about the gears and the buttons, which is always confusing my wife. Using the combination of those controls, you can use what I call mode. It's like a smoking mode or meeting mode. So one shot for multiple controls based on user scenario. And this user scenario can be triggered by the sensor inside the car, the IoT sensor out of the car, and the weather information, the traffic information, maybe the stock price. So it's modularized in ARC. Our customer can just focus on the combination like a Lego blocks. So we have launched ARC in multiple brands in China to enable them build their own modularized turnkey solutions with differentiation of the brand. So and also we keep innovating on new car controls as we think that the car comes more assistant. Next slide, please. So we are very excited to have brought the ARC to the world. And this is what I think is probably one of the world's first AI platform for modularized turnkey solutions. It encompasses our best-in-class conversation AI stack, as well as the best practice of user experience and quality assurance. So we are able to empower our customer to use ARC to rapidly bring state-of-the-art IT solutions, including cloud, client, and edge, into the cars and beyond. The industry IoTs, and enable them to create their own ecosystem flexibly and operate it for their new digital innovation. So now I'd like to show you some example. The new scooter from 70 Mile, the member of Xiaomi. So let's enjoy the video and back to the Udo. Thank you.
小爱同学，播放音乐。待我放松一下，开始导航。前方左转。
我录像。
正在录像。
Thank you, George. I apologize for the connection issues we had while we were going through Udo's section. As we adjust to the new normal of working from home, I guess we're all testing the bandwidth to the limits as kids work from home and dial into their online classes, and we have everybody dialed in at the same time. So let's give it a try again with Udo's section, and hopefully we'll have a better luck this time. Udo, back to you.
Yeah, thank you. I hope the network will work for the next 5 minutes. I would like to resume where I got interrupted. I think we were pretty much finished with that slide, so that should talk about what is inside high level on each of the building blocks, on the core building blocks. And in the next 2 slides, I have a more deeper view on 2 of those engines. So let's go to the next slide. So the first one is our audio AI or speech signal enhancement product. This product is basically shipped with almost all car OEMs. It does signal enhancement for speech input as well as hands-free dialing in a car. As such, it also improves CarPlay and Android Auto acoustics. So it is very likely you use this product every day in your own car when making a phone call. The core modules of this is noise reduction, echo cancellation, beamforming, passenger interference cancellation. And the latter also allows to create a private audio zone where interfering speech or noise from the outside is removed. So for example, you could switch off your kids on the back seat when having a phone call with your boss. Unfortunately, switching off kids only works for your boss in that case, but not for you, as you will still hear them loud and clear inside the car, of course. With deep learning applied to noise reduction, we now also improved removal of non-stationary noises like indicator clicks or wind buffet noise. On that, I have a quick demo for you where you will hear 3 audio samples. First, the original mic signal, then the current state of the art, and finally, our recently launched product. So Rich, if you could play it.
The hogs were fed chopped corn and garbage.
Jazz and swing fans like fast music.
The hogs were fed chopped corn and garbage.
Jazz and swing fans like fast music.
The hogs were fed chopped corn and garbage.
Jazz and swing fans like fast music.
Okay, thank you. So now I would like to move your attention to the next chart on the right side. It will show you another innovation driven by Cerence, where we solved the problem of interfering speakers. It almost happens each time I want to enter a destination in my car that my voice starts talking to me while I still talk to the voice assistant. In the past, this was a recipe to fail. Now I'm safe. My voice still can't wait to talk, but I get the input entered successfully to the voice assistant at the same time. So in addition to that standard signal enhancement task, we also released what Christoph already mentioned now about emergency vehicle detection. So that is all powered by this audio AI product that we have in the stack. So next slide, please. This is our new high-end text-to-speech product that we launched in June with great improvements due to transformer-based networks and generative WaveNet. As you can see in the chart on the right side, it is the best scored TTS text-to-speech globally right now in the category long-form reading, also compared to Google, Amazon, or Microsoft. News agencies have approached us already to talk about newscast the product, and we did sign a deal with a car manufacturer. And responsible over there said, I can't stop listening to this new TTS voice. And you heard a sample from Christoph already. So the software architecture of this TTS engine is divided into a front end on the left side and the synthesis part on the right side, both with different network architectures. The front end does prosodic and linguistic analysis like pronunciation guessing or pause prediction using word embeddings. It also includes encoding of various speaking styles
like news or documentary. And the synthesis part in itself is now completely generative and not unit selection anymore. So completely generative using wave recurring neural networks, wave RNNs. Okay. With that, I'm moving on to my last slide, please. All those basic core tech building blocks form our conversational AI platform, which is clearly the most complete stack with the broadest language coverage compared to any competitor out there. A user request enters the system on the input side by speech, and we get what was said, in which language it was said, who said it, and how it was said even, including the sentiment. So on the natural language processing NLP side, we understand what was meant and who was addressed in case there is multiple assistants active. We'll interpret all that, of course, as well in a context as part of the conversation. And the conversation engine then is there to predict what the user wants to do next, instead of asking a lot of questions, as the best UI, user interface, is the one which has least interaction with the user and still get the tasks done. So for example, we can predict that a user wants to have a covered parking place in case it is raining, even though he did not mention it. Right? We learn such behavior from all the data we get and collect. So in formulating the reaction to the user, we use again natural language processing to generate a prompt based on this context. And finally, the output is synthesized by the text-to-speech in an appropriate speaking style, matching the emotions. In addition to those pure speech input-output, you heard already from Christoph that we can give feedback in different modalities to the user. For example, some feedback that Christoph didn't mention is what we also implemented now in the new S-Class for Mercedes. If you say there, I'm stressed, we'll simply turn on the massage seat. That's also a kind of feedback to the user then. Okay, and with that, I'll hand it over now to Niels, who will talk about new applications.
Thank you, Udo. That's Niels. Pleasure to meet you all and speak to you. I joined the company actually 25 years ago after completing my PhD in AI. I now had the BU for applications that we started recently. And typically when we talk about these apps, we talk about the new business models attached to them, like SaaS models or revenue share. Today, I'm actually going to talk about something different. Next slide. I'm going to talk about what I call the yin and yang of successful apps, because if you want these business models to work, you need user adoption, right? You want people to pick up these apps and use them. And one important thing for that is a great UX or user experience, as we call it. That means a great design, but also a process leading up to it with surveys, usability studies, testing prototypes, and all that good stuff. And my colleague Adam Amfield will talk about this right after my talk. Yeah? I'll focus on the second aspect here, which is high tech actually baked into the apps to make them defensible and make them work actually. So we'll look into this now with a couple examples. Next slides. So the first app I'm going to talk about is called Car Life. It's basically a companion that works with you throughout the lifetime you spend with your car. Actually starting before by helping you to select a model, booking a test drive. Then once you have your car, it proactively tells you what the great features of your car are and how they work. It allows you to ask the car questions about its operation, a smart car manual. It integrates with dealerships for service appointment scheduling and all that good stuff. And it also allows OEMs to push offers and new products to the car. So it's really a great thing. But there's also good technology baked into it, and I'll pick two examples here. I'll talk about the car manual questions and about the proactive feature teaching or onboarding. Next slides. So starting with answering questions drivers might have about their car. It's relatively easy to pick the frequently asked questions, what we call here the short tail or head of the curve. These are questions that are asked again and again. there is a limited list of those, and you can compile good answers and question answer pairs for them relatively easily. But what about the long tail, the many, many more questions some users ask and you still need to answer in order to have a good experience? And that's where we bring in deep learning techniques to come up with a technology we call question answering, which is basically passage retrieval from unstructured texts. So basically, we take texts like the car manual or other texts provided by the OEMs, and we use technology to find the relevant passages, relevant paragraph and sentences that answer the question of the user and answer those. Yeah? And that allows us to combine these two elements, the frequently asked questions and the long tail question answering, to basically cover all the questions in good quality and have a good experience. Next slides. The other aspect I mentioned is proactive feature teaching. By that we mean, imagine you enter a highway, you have a new car, it's in 3 months. The car tells you, by the way, I noticed you've never used lane assist. I see you're entering a highway. Do you want me to teach you how to do it? Yeah, and in order to do it, you need to have this proactive behavior in a smart way. You need to come up with the when and what, right? You need to decide what to teach about and when is a safe and good moment to do it. And we have built a machinery that uses the same reasoning capabilities that both Udo and Christoph mentioned, that we use also for smart domains and making this reasoning about covered parking that Udo mentioned. We use the same to make decisions about the right moments and the right content. And what you see here is a visualization tool we built in order to explain the machinery. You can see how we use factors like sensor input, like is the driver occupied, what is his emotional state. You heard from Christoph how we can measure that. You have information about the driver, you have the content you want to teach. And with all those inputs, we select the right content at the right time. Next slide. Here's the overall architecture. You will find the Q&A engine and the FAQ module in the center and a bit to the right that I covered before. And the proactive module with the AI and reasoning framework you see in the bottom, and together with lots of other components from our standard architecture plus components specifically for car life, like integrations with dealership databases for scheduling appointments and so on. We built the whole car life experience. And you can see here how a relatively easy application, easy to use and easy to understand what it does, underneath has quite complicated architecture and a bit of high tech baked into it. Yeah. Next slide, please. Okay, so the next app I'm going to talk about is called Cerence Pay. And the usual punt I do here is it's all about payments, but everything we do is not the payment itself. Yeah, so this is centered around something like an e-wallet payment gateways that we believe already exist in the OEMs, or we can bring in from partner. What we build is the experience around. We bring partners that have content like parking providers that we announced in the recent product launch here. We bring the cloud and a hybrid architecture we already have in place. We're already in the car, so to speak. We're connected to the cloud in the car. And we bring the user experience that makes it a great experience to pay by voice. This is what it's all about. You can pay by your voice, which is different from starting an app manually on your smartphone or even on the head unit. Instead, you can do it all by voice while still driving, and you will see a nice example in the video that Adam is going to show you. I'll focus here on one aspect, top left, the authentication bit. Next slide. You already heard about voice biometrics from Christoph. Again, here we use it for the purposes of authenticating a person, so to know that a payment is legitimate and they are who they claim they are. You can see it bottom left. And the overall picture here is an architecture we came up with Visa to address a problem that all of Europe has. There is a new payment services directive coming into effect by end of this year. Early next year, which means all payments you do by mobile methods on your smartphone, in a car or other means have to have strong customer authentication, which breaks a lot of the current user experiences you know. Instead, if you don't do anything, you have to go back to the issuer of the credit card. They have to authenticate you, and then you go back to the shop you're using, etc. It's very cumbersome. And in a car, it's especially cumbersome because you cannot send a PIN or something or a token to a smartphone. You cannot pick up your smartphone, enter a PIN. Instead, we solve this by voice biometrics and under a scheme that Visa calls delegated authentication. Actually, the OEM in the car can authenticate the driver using our voice biometrics and a second factor, which can be the ownership of the car, and then there is no step up needed to the issuing bank, etc., which solves this problem. Yeah? So it shows how quite a simple feature is enabled by technology. Next slide. As I mentioned, the whole payment experience is centered around voice, and again, we have proactivity here. I mentioned proactivity in car life, where we select a moment in time to teach you features of the car. Here we use proactivity to actually make you discover that you can pay by your voice. Yeah, you don't have to discover an app buried somewhere in a menu in an app. Instead, we start with requests like navigation requests, which still account for 40% of the voice utterances people do in a car. And we nudge people into understanding. When they navigate to a restaurant, they can make a reservation there. If they navigate to a gas station, they can actually start paying for it while they're driving. And why that works and how people like it, you will hear now from Adam in the next section.
All right, thank you, Niels. And hello, everyone. It's my pleasure to be able to talk to you today. I wish we could do it in person, but we'll make the best of this as it is today. So I'm going to be talking about user experience at Cerence. My role is to lead the user experience and user interface design and research teams. We have a team called the Drive Lab, which is the design, research, innovation, and in-vehicle experience team. And our job is to be the voice of the user at Cerence and to be able to help us work towards the products that will create these experiences that users find enduring, that they want to come back and use again and again. So next slide, please. All right, so we've talked a lot about artificial intelligence and the technologies we build today. And if we were presenting this at an AI conference, someone would inevitably get up on stage and go, what does AI mean? We can't agree on a perfect definition. We're all here for an AI conference, but we disagree on what it means. Well, my job is to ask what it means to the user and what they want us to do about it. And when you think about what it means to the user, they start saying things like, well, AI means you have a system that can learn about me and it can do something with that. It has access to the cloud, it has access to big data, it has access to all of this information that allows it to make these decisions that might be too complicated for me myself to handle. And it may be able to solve things that I don't even know I need solved. It may be able to get to know me better than I know myself and help be proactive and do things like teach me things that I need to know about my car, as the example we saw before. They'll click for me on the slide once. But if I really want to summarize what it is that users come to when they talk about AI, it comes down to them saying, I don't really know what it is. It's really, really complicated. And for us, it's not a bad thing at all because the users don't need to know what's under the hood necessarily, as long as they have a great experience with the way it comes together. Next slide. So AI introduces a huge opportunity for complexity. We're talking about all these building blocks today, all these parts of our technology. We're talking about ones that our content partners have or that the automakers might bring in. There really is a risk of having so much complexity that you end up with clunky experiences. And if you think back, decade after decade, you've seen this in the evolution of technology, where things felt like they were bolted together, often crudely. And sometimes this even seems subtle and wasn't clear at the time. If you think back to the automotive industry, going from some of the oldest automakers in the world, like Daimler and Ford, you'll see that even the addition of a radio in the earliest cars had some user experience issues. They took two great technologies, fused them together, but ended up with a problem where you have all these identical knobs that are next to each other and you're driving. And so what happens if you want to turn the radio up and you accidentally grab the knob to tune the station differently? Again, it seems like it's subtle, but it didn't take into account the fact that while users driving, they're going to be fumbling around with their hands, hopefully with their eyes on the road. And that in of itself was just a small issue that later was fixed. And there are countless examples we could go through, but coming to where we are in the new way today, fortunately for the end user, the vast majority of technology is moving more into a user experience first mindset. And this doesn't, this includes the automotive industry as well, where people start to think around, okay, what does a user need first? What is the user journey going to be like, and how are we going to make that a reality? And the way I like to talk about how we do it at Cerence in particular is to bring art and science together. The art of the pleasant designs, the nice sounds of the voice, the pretty user interface we put in front of you, and the science of the technology. But further than that, as a team with people that come from backgrounds from communications to psychology to engineering, we also want to understand the science of the user. We want to know how they learn information effectively. We want to learn what captures their attention and what doesn't, especially when they're driving. So our job is to try to bring that all together to create these better experiences for the user. Next slide, please. So let me give an example of some of the ways we get at that, and I'll talk about some data we've gotten from this as well. It's really a good idea to test an idea before you invest in the engineering time and money to make it a reality. And one of the ways that my team does that to support our product ideas at Cerence is that we will mock up something. You can see here an example of a restaurant reservation prototype, where we can do a user study such as Wizard of Oz, which means we're behind the curtains, pulling the levers that are making the machine do actions, and see how users respond. Find flaws in our ideas to throw out bad ideas or find new ideas from them, without them ideally even knowing it's a fake system. There are many ways we go about this, that we can test things, but just wanted to give one example of how we take pride in putting these concepts in front of users as early as possible, and then continually to refine based off feedback from those users to make sure that we aren't overwhelming them with that complexity, but creating those simple experiences. Next slide, please. So as a quick case study, Cerence Pay is no different than the other products where we want to lead the design process and the engineering process through research and surveys and usability studies and that sort of thing. In the case of Cerence Pay, I just want to share two graphs here that can give you an overview of some things we learned that help us understand that we believe that we're building a product that users want, they report that we are, and help us prioritize how we're going to tackle it. So on the chart on the left, for the preferred payment method, when we help educate people around what the process looks like, what the benefits are for being able to pay by voice, and potentially any trade-offs with any of these, we find that the majority of people say they would prefer to make payments in their car for various things you'll see on the right, by voice more than any other method. And if you look at those particular methods, paying for parking by voice, gas, drive-through, et cetera, you'll notice that there's a good chunk of those where if you look at just the blue colors alone only, the likely and very likely, we're talking huge margins of people report that they're likely to do these. And because of that alone, we have some guidance here on which directions we would start with Cerence Pay and where we would go next after that. And it's something we'll continue to ask and find out and refine as expectation changes and the product evolves. Next slide, please. So let's bring it all together then. As I wrap this up here, I want you to see a vision of what we think Cerence Pay should be. That was built off of great, clever design, but also based off of research, and will be put together with some of the best technology we have available to us. If you want to go ahead and play that for me.
Hey, Cerence. Get gas.
The closest gas station is Cosmo Fuel in 1.4 miles. This station accepts contactless payments. Want to pay now using your car e-wallet?
Sure.
It will cost $50 to fill your tank. Can I pre-authorize this amount?
Get a large coffee, too.
With a large coffee, your total comes to $53.50. Ready to pay now?
Yes. Authorize it.
Thanks. It's confirmed. Let me know the number of the pump when you arrive. I've emailed you the QR code to scan for your coffee. It will be ready inside when you arrive. Cosmo Gas is ahead on your right. Choose any pump and tell me when you're ready.
Hey, Cerence. I'm at pump 4.
Okay. Pump 4 is ready with your pre-authorized payment. I sent you a copy of your receipt. Have a good evening.
Cerence Pay.
So even if in-car payments aren't the first thing you think about as to where a company may go to improve the experience, I hope that shows that we're looking for all different ways to create these experiences and simplify them for the user in the end. So with that, I'm going to hand things back over to Prateek, who is our guest.
Thanks, Adam. I look forward to using that in my next vehicle. It's pretty cool. With that, we'll move on to our fireside chat section. Joined with me today is Charan Lota, Chief Engineer, Connected Technologies, Toyota North America, for a discussion on role of AI in the future connected vehicles. Thanks, Charan, for your time today, and we're honored to have you as a guest here today for this virtual chat.
Thanks, Prateek. Interesting presentation so far. Really enjoying it. Thanks for having me.
Great, great. Well, first of all, before we get started, as a disclosure, I want to state that my first car was a Toyota Corolla, and since then I've owned a Lexus and a Camry hybrid in my life, so I'm surely impressed by the technology, the quality, and the work you guys doing. So just as a background. So Charan, as we talk about connectivity and electrification, which is the connectivity and connected car is the buzzword today. As a chief engineer for Toyota, how critical is the connected car to Toyota's future products?
Yeah, good question. You know, connected cars are basically now the expectation, right? They're no longer viewed as an optional feature. I think when somebody goes to buy a vehicle, they fully expect it to be connected. And if it's not, there's going to be a disappointment, right? The reason is that connected car, you know, it enhances countless user experiences. You know, everything from safety, freshness of data, you know, as well as providing convenient time-saving features. Just like the video that we just showed previously, you know, I was watching. It's to me, who wouldn't want a feature like that, right? So overall, I strongly feel that, you know, connected car is key to the success of our brand, Toyota. So yeah, for sure.
Well, you said it very right. I think the freshness of the data, the content, it surely adds to the user experience. So how important is it for Toyota to retain the brand and ownership of the human interaction, the user experience inside the car?
Yeah, no, it's very important. Honestly, it's super important because, you know, customers in our vehicles, they're guests of Toyota, right? And as guests of Toyota, it's imperative that we carefully manage, you know, the UI, UX, the user interface, user experience to ensure that, you know, we provide a consistent user experience as well as safe, right? We got to manage and balance both of those things. You know, even when we bring in third-party platforms, which is in some cases, it's absolutely the right choice to make, you know, we still take pride in seamlessly integrating those platforms into our ecosystem, right? And that is one of the big keys to building trust with our customers and with our products. So yeah, very, very important.
Great. I agree fully. I think Toyota has been known for brand and technology in the auto sector, and it totally makes sense to retain and build upon it, right? As you said. So how do you view the extension of a consumer's digital life from outside the car to inside the car?
Good question. You know, I can just think about personally, you know, nobody enjoys spending their Saturday morning syncing various platforms, whether it be their vehicle, a new TV that they bought, any technology, right, that you buy. And a vehicle is essentially a piece of technology that you bring home, you know, albeit a very expensive piece of technology can get to be. But, you know, and if you think about that and you couple that with, you know, the last decade, we've seen a rapid expansion of platforms available in the market, you know, and, you know, as a chief engineer, I see all these platforms come. We have to take a decision. Do we integrate? Do we not integrate? How do we make it seamless? Everything from music to video streaming, social media. There's a lot there, right? And Toyota is a global company, and all of these different platforms, they differ across which region you're in, right? Whether you're in China or Japan, Russia, Australia, they typically have different platforms. There's very few platforms, like a Google or an Apple that go across the globe. And overall, ideally, the transition from outside the vehicle to inside the vehicle is seamless. That's my charge. That's my task to make sure that that happens. And we're always working towards that goal. It's not easy, but it's something that we must make that transition. It should be just as easy as possible.
Great. Well, I cannot agree with you more here. I mean, in the beginning of the session also, I said that even I'm using several different technologies in my personal life as like other users, and seamlessly accessing all those apps and those technologies in the car would just remove so much of the complexity. So totally makes sense. Now let's talk a little bit about the voice assistant in the car. So what do you think are the advantages of an embedded virtual assistant over something like bringing your phone and tethering in the car? Is this distinction important for Toyota?
Yes, it is. And the importance is simple for me, right? Anytime you embed a system, it just allows for a quicker and more seamless user experience, like I mentioned before. In turn, then this can actually allow to make for a safer user experience as well. As the tech grows inside the vehicles, you have access to a lot of these things via touchscreens and physical controls, and even that can get complex if we don't manage that very carefully. Voice is always a quick way to just access features and functions. I use voice around my house all the time to turn on the lights, turn on sprinklers, everything. Any gadget that I can get my hands on that I can connect to voice. At first people don't use it in the family. My family's not using it, but eventually, once they see me using it, everybody's using it to turn on yard lights and do whatever. But in short, embedded voice allows just Toyota to quickly access features and functions. And it just allows to do things quicker, right? Set temperature to 70 degrees, done, right? I don't have to look around for the volume knob, the knob for the temperature or anything. It's just that easy, and it's just got to work though too. So.
Sure. I sometimes feel I'm getting lazy by all those smart home things, but yes, it's definitely very enhances the whole user experience and is very intuitive. And we're at Cerence, we have been investing on making the virtual assistants very human-like. So I agree with you. Now, since we're talking about AI today, and Cerence is an interactive AI company, what role do you think AI plays in the Toyota vehicles in the near future?
I think there's a key role, and as Adam's presentation came just before mine, that was actually quite perfect. But the AI, the term itself, as was mentioned, it's quite broad. And honestly, the applications are limitless. They're up to the ingenuity and the creativity of the engineers working on it. And just my assessment is that AI is going to allow Toyota to deliver a more personalized user experience for our guests, right? But one of the keys here is that we have to show restraint, because sometimes tech for the sake of tech, it can lead to unnecessary complexity as well as annoyances, right? Think about just getting suggestions or videos popping up when you're surfing the web, or we have to basically manage that really carefully. And if the customer doesn't see a benefit from any feature made by AI, we should restrain ourselves and not offer it. But overall, I'm really excited and about thoughtfully integrating AI into our connected experience overall. And we're just looking for the ideas from our engineers and seeing, building proof of concepts and trying to get some stuff out there for sure.
Cool. Well, we have been making at Cerence as well the great advances in AI, and we've talked to you and discussed with you as well to get your feedback. And I think obviously, as you said, the technology is vast, and this is just the beginning of where this tech will end up, right? So we also have some great products lined up in the space in the future. So maybe we have time for one more topic. This technology that you talked about, do you see this expanding across all the models and brands of Toyota? And how long in the future do you think this is?
Yeah, I think it's most definitely the technology will expand across the lineup. That's only natural, right? Any technology that comes out to the market and the consumers are truly enjoying it, and it's time saving and it's value add, we have to take a look at that, and it's a progression, right? But as Toyota, we're now in the process, and always have been. It's a careful make versus buy decision, and leveraging platforms and partners, right? So our ultimate goal is let's spread this tech across as much as Toyota and Lexus as possible. Gone are the days that says, hey, listen, when tech comes, it only goes to the flagship model, right? It goes to the top of the top, and for us, that's Lexus LS. That tech is now expected by people that are buying a Corolla or a Yaris, and we have to figure out ways to get it there. But I can't give specifics, how long it'll take. What I'll say is that in my team and inside Toyota, there's a sense of urgency to get to the market quickly and make it affordable as well. So, and again, Cerence is one of those key partners that we look at, when looking at, tech, voice tech. You guys are really doing an excellent job in this arena, and, kudos to that. And, ultimately, partnerships like that, this help us significantly to get things to market quicker.
Well, that's really great to hear. We're always cheering for Toyota and look forward to the new products from you. Well, Charan, thank you for your time today. And thank you so much for coming on to this virtual chat.
Fantastic. Thanks, Prateek. Enjoy the rest of the showcase here.
Thank you. With this, I'll pass on to Rick to talk about innovations in action.
Excellent. Great. Thank you, Prateek. And a special thank you to Charan for joining us today. It was a great discussion, and I appreciate the support of you and everyone at Toyota over the years. So hi, everyone. My name is Rick Mack. I'm the Chief Marketing Officer here at Cerence. I joined the company at the time of the spin, following a great tenure with this business in a number of different roles at Nuance. There are a lot of familiar names on the registration list, so great to speak with many of you again today. So you've heard a lot from the Cerence team, a strong core, a deep technology stack, leadership in conversational AI. You've also heard about new offerings that package a best of Cerence into turnkey products, new applications that provide not just new revenue streams for us, but also for our customers, and in turn, convenience for drivers. And the all-importance of design, that blending of the art and the science to create a really great experience. And then, of course, none of this is possible without the enduring support of our customers and partners all around the world. So I'm here today to show you how we bring it all together, that innovation, the experience, the design, the partnership, to show a great example of something exceptional. Next slide, please. So with exceptional in mind, there's probably no better nor timely example than the latest version of MBUX. So MBUX is Daimler's Mercedes-Benz user experience. The latest version was just unveiled in July, and more recently was a headliner as part of the new S-Class launch just earlier this month, and really underscores the importance, as Charan just noted, the importance of technology in today's vehicles. It really is state-of-the-art for in-car conversational AI, which is an important term and concept that I'll return to in a moment. It's also a little bit of an awakening, a great reminder that our cars have really become the next great computing platform when you see what this system can do. It's not just about the assistant or automation or convenience, but rather it's about how the experience comes together, how it's all packaged, and how it's going to make you feel. It's where high tech meets luxury. And of course, as you know, Cerence isn't just relegated to luxury. This same high tech is available to and found in all sorts of makes and models and brands around the globe today. Next slide. Excuse me. So this is really the culmination of a true partnership between Cerence and Daimler. It's probably decades in the making, going back formally to 2003. It even predates that a little bit further when you consider certain team members here at Cerence, such as Udo Heiber, who spoke earlier. It was part of the Daimler team back in the late 90s that built one of the first voice UI systems for the company. Now, we've thrown a lot at you today. You've heard a lot about these innovations through the presentation, so I'm not going to go into detail for each. But I do want to make sure for the ones that you see here that you understand what forms the backbone of MBUX, working close partnership with them to truly make the system possible. And from these innovations, we hear tremendous praise coming from early test drives and even Daimler competitors that have experienced it firsthand. We've thrown the full weight of our R&D, innovation, and services programs at the system. Cool features such as voice from every seat, biometrics for new levels of personalization, and the ability to just talk, to name a few. And because these are all connected vehicles, you have the opportunity now for over-the-air updates. So you should expect new features, new capabilities to emerge in future cars and versions. Next slide. But the innovation is really just the beginning. The innovation is that backbone, that science backbone of the car. For the true experience, that also has to be married to an art, as you heard from Adam, to build something so elegant, or in the words of one of their reviews, really mind-boggling. Across the board, our teams accomplished remarkable things. With more than 300 Cerence professionals working hand in hand with their Daimler peers, work coming out of every major office, from Aachen and Burlington to Montreal and Chengdu. Integration with hundreds of sensors, a great reminder of the complexity that is only growing in these connected vehicles. Geographic cloud centers to create that global experience and the OTA capabilities I mentioned. And then finally, packaging it all together for a global audience, 27 languages. All of this comes together, the art, the science, the innovation of Cerence to create really something special, something quite unique. Let's take a quick look.
Hey, Mercedes. How can I help? I am so annoyed today. Then do things that don't annoy you. Call Thomas. I'm calling Thomas on the private number.
Accept.
So this, of course, is only a glimpse of what's possible out there. I encourage you, if you haven't already, to take a look at the full complement of Daimler videos and materials to really appreciate how special it is. You could go to the next slide. So when you think of special in terms of innovation, we're often reminded of this famous quote, and I think magic is really the operative word here. You know you have something special when the technology simply vanishes. It disappears and it delivers a great experience. And that's exactly what we've done. It's natural, innate, and incredibly compelling. So recall the earlier references to conversational AI, and that's what we have. Many talk about it, but Cerence is one of the rare few that can actually deliver it no matter the industry. It's the ability to have a true conversation, not that ask and get that we all know, but more the ability to just talk and get information, to spark an action, to create an experience. So after that initial engagement, there's no more okay assistant for every command. Just as you and I would never say okay Debbie and okay Rick before every sentence. You can talk to the system for the entirety of your journey if you wanted to. We've eliminated that wall. The technology vanishes, and what remains is truly conversational, extremely comfortable, and incredibly easy. We think conversational AI as it's really meant to be. Next slide. But you needn't just take our word for it or Daimler's. MBUX has received universal praise, mind-boggling, smart, game changer, to highlight just a few. We're incredibly proud of the innovations and of the system. We're incredibly happy for Daimler and all its success and thankful for the company's support. And we're inspired by the reactions, which in turn motivate us again to lead what's next around the corner. Next slide. So as you saw from my colleagues today, we're already building the next systems for OEMs around the world. We're expanding our markets, as you see here. We're pushing the boundaries of what's possible and delivering on our promises. I don't think there's a better moment for Cerence than now. We have the core, we have the vision, the people, that drive for success going into the future. We look forward again to bringing it all together, continuing this groundbreaking work in partnership with Toyota, Daimler, Ford, Hyundai, Geely, and of course, countless others around the world to create that safer, more enjoyable journey for everyone. I want to thank you for your time today. I know it's precious. I'll turn it back to Rich for some closing remarks. Take care.
Thank you, Rick. And basically, that's it. That's we're bringing the event to a close. I hope everyone, benefited from learning from the staff of deep engineering and product talent that we have here at Cerence. And if you have any questions, please feel free to follow up with me, and I will make sure we get answers to those questions for you. But thank you for joining us today, and look forward to speaking to you again in the near future. Thank you.